Hello. Thank you for a warm welcome. Let's start, shall we? My name is Hubert. I come from the Białystok, which is close. I mostly do Ruby on Rails on a daily basis for years after years after years. I'm doing quite a lot of JavaScript as well, and for about a year and a half to 2 years, I've been doing more and more Elixir on my daily basis. I'm a coder myself, but I'm also an entrepreneur, which means I run a small company and we hire people. And this is relevant because we're actually going to be talking a story about a new hire that inspired me to prepare this presentation. So, sometimes when we're hiring a new developer, especially if it's fresh university graduate, like in this very case, I like to run some sort of trial project with that person. And so did we here. So we started a brand new project, and I wanted to assess her design skills as well as research skills. So the first task that this programmer was given to was to actually make some research and come back to me with ideas how to implement the project. It was a tiny project, something to allow us visualize the virtual machines running on one of the projects and see, I think they're load or something like that. But there will be like multiple user accounts with different access as well. So I thought, okay, this sounds like a cool little project. Let's try doing that. And the next day, she came to me with 2 sheets of paper. On the first sheet of paper, there was a database design. And I was like, oh, we probably you're right. We probably need a database here in this project. I didn't think about it. I didn't think that was that relevant at this stage, but okay, that's cool. So I'm looking at this this database design, and there are those little tables everywhere. The sheet was full with all those tables, little boxes, and connections between them, but one table was kind of special, and most of those boxes pointed their associations to that very table, and she also tried to avoid crossing the lines, so the lines went around, and there was like a users table, which I figured, okay, that must be really important part of the app in that case, if everything's pointing to that direction. And I had to look at it and I said, I don't care. That's not probably, that's okay you did that, but I don't really care how it's gonna look like. Probably most of the operations we're gonna run will be just hitting the API of the Amazon and fetching the data and just rendering something on the fly. And she was like surprised, like how you cannot care about database design. And this got me thinking, like, why did she start the project, thinking about the project from thinking about the database? And I think the answer is because we've been told to. We've been told too many times to start thinking about the project, thinking about the data it's gonna store and how it's gonna look in a database, stuff like that. And the truth is that this is sort of like a default. We're starting a project and we need a database. Our web apps, like for example, if you program in Ruby on Rails, generate new project, by default it's not even gonna start without the database. So you have to create a database in order to run a simple hello world in Ruby on Rails. And our tools usually ship with something called ORM, Object Relational Mapper, and in Ruby on Rails, that's Active Record. And it's pretty straightforward Object Relational Mapper that maps the tables in database to classes in Ruby, and the individual rows from those tables, they're gonna end up being instances of those classes. So in case of the user model, we're gonna have the users table, and the class is gonna be user, and the instances will be instances of that class user. And we're gonna use that user model in most of the application in different parts of the app. So we're gonna use it to build our registration form, where the registration forms fields are gonna map more or less directly to database fields in our users table. The thing is, the context matters, so we're gonna use the same model in different areas of the application, and we're gonna end up with some conditional code that we're gonna put into our user class to support registration and maybe then the updates by the admin system to the user model. And we're gonna end up with a bunch of unreadable code that, because it's unreadable, quite likely it's gonna be also insecure because we're gonna miss something. If you map directly the users columns into the fields of the object into the database, you might have something like isAdmin, and I actually seen application where you could add a hidden field in the registration form saying isAdmin equals true, and you could register yourself as an admin. So this is not great, but I had a look at the second piece of paper she had, and that was a class diagram. And it was pretty. It was a really pretty diagram, like a UML diagram. I haven't seen one in a while, so it was nice to have a look at. It mostly mapped to the table diagram, which was really, really similar. Most of those classes that they mapped directly to the database columns and tables. However, when we've been taught about the object-oriented design, there are some things that we know what's a good design, what's not a good design. One of the aspects of good design is that you don't have to really repeat yourself that much. So we have the techniques that allow us to share the common behavior, like inheritance. And I had a look at the class diagram she wrote, and we not only had a user model, but we also had an admin user that inherited from one another. And I said, cool, that looks really cool. And then those two users, user classes, they were related to other parts of the code using the polymorphic associations with other objects in our system, and I thought, yeah, that's cool. However, the answer is that's not really cool if we do it this way. The tools that we're gonna use, the object relational mapper, it actually allows us to do both things, to map the classes and make inheritance. However, I largely found that these are false hopes, that our code is going to be structured nicely if we're going to go toward that direction. So those are mostly unmet promises. How inheritance would have been done using active record in Ruby? We would have a type column in our database tables. So the instances of the classes, so the ORM would have to figure out the instance, the class name, and instantiate the objects accordingly. So we would have like a type column that says either user or it says admin user. However, if you think about the rows in a database, they're basically tuples of data. There's an ID, there's some other things, and different attributes, there's always the same size of such tuple, So we would end up with the same attributes carried over from the base class to the parent class. So the basic user would still have the same attributes as the admin user would, because they share the same underlying table in the database. So the issue with this unsecure registration form would possibly still be the case. The polymorphic associations is the other thing which we can do if we want using object relational mappers. However, how is usually done? How is done in Active Record and a couple others is that in our database, instead of having the database foreign keys, like for example user_ID that references the user row in a users table, we would end up having two columns to describe our association. There would be like owner_ID and owner type or owner class. And this actually nullifies some of the advantages of using a relational database. For once, if you do that, you don't rely on the database foreign keys like at all. This has to be handled in your Ruby code, in the code that your library runs. So it's going to be difficult to maintain consistency on database level. The other thing is that you lose some advantages like doing easy joins, because you cannot easily join 3 different tables. We also have a leak. Like if you think about that design where we have this user and it's being passed from the bottom layer of the app for the controllers to our views, and then it's going to get serialized to JSON, possibly sent to the API. So this object goes through all the layers of application quite easily, and it doesn't really follow good object-oriented design practices like single responsibility principle. It does everything. It's basically a godlike object. It knows how to serialize itself to a database, how to read itself from the database, and how to query it and stuff like that. In addition to that, those objects they also handle stuff like transactions and obviously our business logic. So stuff like validations, conversions, calculations, etc., etc. A lot of programmers in my field, in Ruby field, would just put those into models. This thing, those sort of problems that we have when we use object relational mapper that maps our tables to objects, it actually is not a new problem. This is something that the programmers of the yesterday have been struggling with, and we're still struggling with the same issues after, I don't know, 20, 30 years. So maybe they've been using Smalltalk or some early Java, but they had exactly the same issues, trying to fit good object-oriented design into constraints of the database. There's a second name for that issue, is the Vietnam of computer science. And there's a blog post. If you Google it, you're gonna find the blog post. That's already fairly old, so the Vietnam War is been going on still since it's been published. And it doesn't really look like we're winning this battle at all. So let's think about the solution. Do we have any solution? Of course, there's NoSQL databases, right? You can serialize your objects more easily, and for example, if you don't want to have some field, then you're not gonna have it, right? Sounds like a good solution? Not really. NoSQL databases are something to consider, definitely, but you're probably still gonna need relational database to perform your queries, to do some analytics, fetch some stuff, and you're gonna hit a wall with NoSQL databases that were not designed to do those sort of things. They're also immature. Relational databases have been around for, what, like 40 years, maybe? And NoSQL movement has started like maybe 10 years ago. So they've been popping up and disappearing throughout that time, and well, they're less mature than relational databases. So there's one more thing which you could use is the object databases. There are things like that. Smalltalk has some. However, if you have a look at your favorite programming language, you're probably not going to find object database that you could use straight away. There's one for Ruby for sure. However, it requires special implementation of Ruby that's not really compatible with the whole ecosystem. So you're losing the advantage of using, you know, your favorite tools anyway. So just to have the object database, which might be fine in some cases, but in most cases it actually won't be fine. I have a partial solution that you can start using straight away, is to put your object relational mapper and the classes on a diet. Just limit their limit what they have to do as much as possible. Don't put any business logic inside. Don't put any validations into your models. Just keep them as short and concise as possible. Limit them to define associations between tables and stuff like maybe there's something that allows you to query those tables easily. Just put those things here, and even though your tool allows you to do so, like have more stuff, more code into your models, just don't do it. Just limit yourself. Instead, move your code to the places that you control yourself. Take control of your objects, design your objects into application yourself, and treat your database as it was intended to. It's a database storage engine where you save stuff and you read it from, but the objects you interact with your code needs to be your own. And if you think about that solution, the partial solution, you end up realizing that the stuff we read from the database and we save to the database is just data, and we moved out all the functions that operate on the data to separate part of the thing, part of the code. So it sort of looked like a functional programming to me. It starts to be this separation between data and code, which is really, really nice. So that comes to the second part of my talk. It's about how our web applications, they use the underlying database. And back in the day, when we started building web apps, maybe 10, 20, 15 years ago, it was pretty simple. So a request came to the server, it hit a database, loaded some stuff, then rendered the HTML. The HTML was sent to user, and that was pretty easy. And then probably there was some big interval of time between one user performs two actions. But the web has changed. And the batch processing, as we can call it, those requests are a thing of the past now. So nowadays it's more look like an interactive programming. So our websites, they don't just load and they wait for the user to click on the next link or submit a form. There's a lot of stuff happening around this page. They can request a dozen of stuff from the backend whenever they just load from the JavaScript. And then user clicks on something on this website, and this website doesn't really reload at all. it just wants to fetch some more data from the backend or save some data, but the user stays the same. So these are rich user interfacing we're building that perform complex tasks. However, our server-side code stays exactly the same. Whenever we have like 5 API requests to the backend, each of those requests is still separated from each other. They are stateless. So we end up with a stateful user interface in the browser and a stateless backend server-side code. The thing about it is, if you think about how the backend performs, is that it's doing quite a lot of unnecessary work if we program our stuff this way. Most importantly, it's abusing the database by hitting it with the same requests all over again, while half a second before it already knew what the current user was. So why do we load it again and again? The answer is the tools of today force us to do so, especially if you do something like Ruby, where concurrency is really weak. You don't really have a way to persist those objects between requests. So it has to scrape everything and then recreate from scratch, which is expensive. You have to realize that stateless is expensive. Object creation is expensive, then garbage collection is also expensive. So why don't we just keep those objects in hand while the user is interacting with the website instead, to save some reads and writes. Moreover, if we're gonna do that, if we're gonna keep those objects in memory, we can save ourselves some trouble with something like conflicts on a database level, because we can resolve them in memory of our application. That all can result in better user interface performance, so we don't see that much. But we need tools. The tools of today, they're not great, they're not created for that. And if you think about what's the analogy to the modern interaction with website, it's not like a batch processing, it's not like a mail where you request something and it's sent to you. It's more like a telephone connection with somebody else on the other side. So you request some data, you get it, then you request it back, get it back. We already have stuff like WebSocket that allow us to open those persistent connection between our frontend and backend, so we don't have to repeat ourselves with those API calls all over again and again. And why don't we just fetch the same tools that they use to build those telephone systems and apply them to the web programming? Sounds like fun. And in fact, there's Erlang, which you can use, which is great. There's also Elixir, which I believe there was another talk today also about Elixir, which is it's a programming language that runs on top of Erlang VM. And those tools, they are parallel than our like Ruby or possibly Java or other programming languages. And they give you actually more control over the state. Some people think that functional programmers, they hate state and they try to avoid state as much as possible, which is not true. We like to take control over state and make sure it is correct. Erlang and Elixir, they come with a set of libraries, it's called OTP, and they have ready-to-use abstractions like GenServer to create long-living objects. They call them processes, but basically they're like long-living objects that run in parallel to each other, and you can create those when the conversation starts, keep them in memory while the user is using the app, and then there's a mechanism to shut them down or suspend them and then recover. So you have all the tools you need to build a stateful backend today. So that gives you a lot of advantages. Your business logic now is all into the application. It's not in your database, and you free yourself from those database constraints altogether. It allows you to use your database in the way it was intended to initially, in a way that it's actually good at. It's definitely not good at fetching and saving the same user model 5 times within a second, but it's really good to load a complicated SQL query, so use it for that. Bonus. I found it, those tools, Erlang and Elixir, are really good if you're trying to do something like domain-driven design, which usually we associate with stuff like, I don't know, C# or Java, where it's big. But actually in Elixir and Erlang, in functional languages, your aggregates map directly to join servers. That you can do this, limit the parallelism using those abstractions. So all the building blocks to build domain-driven design application are in there as well. In addition to that, when you keep stuff in the memory, you keep stuff on hand, so you don't have to hit your database that much. You get the benefits of scalability, that you can return data faster and scale a bit more easily than having a database that's going to be a bottleneck at some point or another. You're using the database less, so if you add more of your front-end nodes that sit before the database, you're going to be able to scale it better. So, to sum up, I think the future is stateful. We have the tools to build stateful backends. We have the tools that allow us to not abuse our databases, end up with better code design, and we can start using them now. Have a look at Erlang, have a look at Elixir, or maybe there's something in your favorite programming language that you can use to build those sort of things too. Thank you very much.